Okay, there are three properties of logarithms we're going to be using today: the product property, the quotient property, and the power property. It is not important for you to memorize the names. The product property basically says that if you have a product inside the log, so inside log base b, we have u times v. Multiplication inside the log is the same as addition outside of the log. So this splits into the log base b of u plus the log base b of v. So each thing inside that log gets its own log, and they are connected with addition. Those of you who are familiar with properties of exponents, you might find this interesting because when we're multiplying exponents with the same base, when we're multiplying two things that have the same base, we add the exponents. So what we're doing here is, if there's multiplication inside the log, we are adding. Over here, I'm going to write a little table that says inside and outside. So, multiplication inside the log is equivalent to addition outside of the log. And I drew a double-ended arrow because if you have addition outside of the log, you can condense that back into multiplication inside the log. So if multiplication and addition are linked in this way, what do you suppose is going to happen in the quotient property when there's division inside the log? Subtraction. So log base b of u minus log base b of v. The power property is kind of an interesting property. It says that if there's an exponent inside the log, that exponent will move down in front and become a coefficient multiplied in front of the log. So n times the log base b of u. I'm going to show you both the long way and the short way. The short way might be a little confusing at first, but as you get familiar with these properties, the short way is the one that you're probably going to start gravitating toward. So the first thing I notice here is the division. And I know that division inside the log is the same as subtraction outside of the log. So I'm going to split this into the log base 2 of 7x to the third minus the log base 2 of y. So first I notice the division and I change that to subtraction between the logs. Next I'm going to notice the multiplication between the 7 and the x to the third. So that first log base 2 of 7x to the third splits into log base 2 of 7 plus log base 2 of x to the third. And then we still have minus log base 2 of y. Then I notice that we have an exponent of 3. Exponents do not stay in a log. Exponents move into the front of that particular log. So we still have log base 2 of 7, but this one becomes 3 times the log base 2 of x minus log base 2 of y. A fully expanded logarithm has only one thing inside each log. So one number or one letter and no exponents. That all has to get moved around and simplified out. Okay, Now, what I want you to notice is the stuff that used to be on the bottom inside the log is now in its own logarithm with a minus in front of it. The stuff that was on the top of the original log is in its own logarithm, and there's positives in front of them. So there's like a positive in front of this first one, but we don't have to write a positive in front. So here's my shortcut. Basically, it's just being really familiar with these properties. I see that there's 3 things inside this log. So I'm going to write 3 specific log base 2's. The first thing is 7. The next thing is x to the 3rd, but exponents have to go in front, so I put my exponent in front and the x inside. And the other thing is y. Now I simply have to decide plus or minus in front of each log. So the y was on the bottom, it needs a minus in front of it. Everything else is a plus. And bam, I'm done in basically one extended step. Again, the short way might seem really confusing, but once you get familiar with these properties, it's sometimes easier to just do this the shorter way. Would you like to try number 2 on your own? Okay, try number 2 on your own. Okay, my class has requested that I do the short way first and then expand with the long way. So the short way, I'll use green for the short way so I'm consistent throughout. The short way is look inside the log. How many things are inside the log? There's 3 things. There's 25, there's x to the 6th, and there's a y. So I'm going to write log base 5, leave a space, log base 5, leave a space, log base 5. Okay, the first thing is 25, so I'm going to write 25 inside that first log. The next thing is x to the 6th, but exponents, what's the rule with exponents? They go to the front. So we have the 6 in front, and then we put the x in, and the last thing is y. Now these are all multiplication, these are all on the top, there is no bottom, so these are all connected with plus. Okay, the long way would be to do this step by step, to start by saying there's multiplication in between all of these. So we write log base 5 of 25 plus log base 5 of x to the 6th plus log base 5 of y. And then you have to look in that list and see, is there anything else that we can do? This exponent of 6 needs to go in front, and that would give us our final answer, which is already written in green. If we do number 3 the short way, how many things are inside that log? 4 things. There's a 9, a y, a 1000, and an x squared. So I'm going to write out log of 9, log of y. Did you notice this is log with no base? That means it's base 10. We don't have to write it, but it's base 10. Okay, and then this last one, log of x squared, remember the 2 goes in front. Okay, now this one's a little bit weird because there's 2 things in the denominator. Okay, the log of 9, that's on the top, so that's a positive. Log of y, that's on the top, that's a positive. There's multiplication between those. Some people would say, hey, there's multiplication between the 1000 and the x squared, so there should be a plus between those. That is fine, but if you do it that way, you need to put parentheses and put a minus in front of the parentheses. So you're saying divided by, and all of this stuff is going to go on the bottom. The other way to do this, and both of these answers are correct, and this is the way that I personally prefer. 1000 is on the bottom, so minus log of 1000. X squared is on the bottom, so minus 2 times the log of x. Anything that was on the bottom in the original log is going to have a minus in front of it. Anything that was on the top is going to have a plus in front of it. And I prefer the second way because that's how you're going to see more logs when we do the next step, which is condensing. Long way. I notice that there's a coefficient. I want to start by fixing that coefficient and putting it back as an exponent. So that 2 goes back as an exponent. The addition condenses back into multiplication. And then the division, or the subtraction, becomes division. Okay, now why did I rush through that so fast? Because now I'm going to show you the short way. The short way is, first, see that you've got an exponent situation there, but you're going to have log. The 6 is going to be on the top. The 2 squared is going to be on the top because those both come from logs that have a plus in front of them. The 3 has a minus in front of it, so that means the 3 is going to be on the bottom. And that's your answer. Try number 5 on your own. The first thing you should always look for is coefficients, and honestly, it might be a really good idea for some of you to at least write that step. Even if you feel like you don't want to write multiple steps, writing that first step of changing those coefficients back to exponents can be very helpful for you. So this is log base 3. 7 squared, that's from a log that is positive. There's no negative in front of it, so it must be positive. So 7 squared goes on the top. X to the 5th comes from a log that has minus in front of it, so x to the 5th goes on the bottom. Okay, try number 6 on your own if you haven't already. Okay, the first thing you should do every time you're condensing is look for coefficients. Those coefficients, the numbers in front of the logs, they have to go back as exponents. So your first step should be to rewrite it, moving that 2 back to a square, move the 3 back to a third. So move those back into those exponents. Okay, the x squared comes from a log that is a positive log because there's no minus in front of it. So the x squared is going to go on the top. The 5 comes from a log that has a minus in front of it. So that 5 is going to go on the bottom. The y to the third comes from a log that has a minus in front of it. So y to the third will also go on the bottom. If you have the log base 3 of 47 and you need to evaluate this in a normal calculator, you do log button 47 divided by log button 3. Log button on your calculator is base 10. This is base 3, so you can't type in log base 3 of 47. But the change of base formula allows you to use base 10, which is your log button, and do log of the number inside, 47, divided by log of the base, 3, and that will give you what log base 3 of 47 is. I believe someone with a calculator, is this 3.5? 3.5 approximately. So whether you use your fancy log base feature on the fancy graphing calculators, or whether you punch this into a scientific calculator, you will get 3.5 something something something.